Hello and welcome. Today we're going to take a look at another Leetcode problem called valid anagram. It's number 242. Given two strings s and t, return true if t is an anagram of s and false otherwise. So here you have the examples anagram and nagaram. Output true because they contain the same letters. And example 2, rat and car. And here we have false because because C does not appear in rat or T does not appear in car. So we do not have the same letters with the same frequencies in that case, so we return false. And then we have a follow-up. What if the input contains Unicode characters? How would you adapt your solution to such a case? Okay, and we have some constraints as well. S and T consist of lowercase English letters. That's the important one. Okay, so let's go to the drawing and see how we could approach this problem. So we have here two strings, anagram and nagaram, and then we have the other example as well. But first, let's take a look at the first one. So here we are interested in the frequencies of letters, right? So for the first word, we have the letter A appearing 1, 2, 3 times. The letter N appears 1 time. The letter G 1 time. The letter R 1 time. The letter M 1 time. And then we have the word nagaram. And here we have A appears 3 times. N appears 1 time. G appears 1 time. R appears 1 time. And M appears 1 time. So we can see that we have the same letters with the same frequencies. So in this case, the two strings are anagrams. So we can easily compare this using a vector or a map. But since we have the follow-up question that asks us for support for Unicode characters, not just regular characters, a map might be better suited because then we can extend it to support whatever characters we need. So we're going to implement this using an unordered map, which is the HashMap in C++. And yeah, you can see that by comparing the frequencies, we can get to a result. So you might say, oh, do we need two maps then? Well, no, we don't, because actually what we can do is we can just say frequencies of word 1 minus frequencies of word 2, right? So if we subtract all of these, what do we notice? We notice that we get 0 for all of them, right? So 3 minus 3 is 0. For A, for N, 1 minus 1 is 0. G, 1 minus 1 is 0, 0, and so on. So here, minus, 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 minus. We have 0 for all positions. So in this case, the string is an anagram. Okay, so what about rat and car? Well, for rat, what do we have? We have R appears once, A appears once, and T appears once. And for car, we have C appears once, A appears once, and R appears once. But notice that T and R, T and C will not match. So when we do minus, we have to do, here we have T0 and C0. So when we compute the difference between these, we're going to have the difference for T is going to be 1, and for C is going to be -1. If we do the difference, right? So therefore, these are not anagrams. These strings are not anagrams. Okay, so that's it for this problem. There are some small optimizations that we can still make, but let's go and code this. Okay, so we said we're not going to use a vector, we are going to use a map so that we also answer the follow-up question. I'm going to call these frequencies, and an easy way to do it is just you iterate for the first one, you iterate for the second, and here we say and then we ask for each item in the map, and if the frequency, which is the second one, is going to be equal to or not equal to 0, return false, and then we return true. Okay, so we iterate to this first word, we compute the frequencies, then we iterate to the second word, we decrement the frequencies. So here's where we do the difference in the same map. We don't need two maps. And then we just compare. If the element is not 0, we return false, because all of the elements, all of the frequencies should be 0 for the strings to be anagrams. And then we return true. And then there's one more thing we need to check in the beginning, that the size of the strings are the same. If the sizes are different, then they cannot be anagrams, right? So that's not possible. Okay. Accepted. Accepted. Okay. So what else can we do here? Well, what we could do also is, instead of having these two loops here, we could just say and then we just have one for loop, right? That's one thing we could do. And another thing we could do is to optimize this another way. We notice here that when we compute the difference, we can straight away check if the frequency of the character is less than 0, then we return false. And actually, right, because if you will always decrement here, and if we get to a negative number, it doesn't matter, it's -1 or whatever, -2 or any negative number, we return false, because the moment we have a negative number, we're just going to go even more negative with future characters possibly, but we'll never go back up to 0. So in this case, we return false. So this is an optimization. And what we notice is, because even if there's a new character in S, you might think that we still have to check the for loop in the end to check if the rest of the elements are 0, but we don't, because if we have such an element, we'll also have another one in T for which we'll have a negative result, which will have a negative frequency. So this is enough to solve the problem. Right, so you can see it passed. Sometimes this runtime here is pretty random. If you submit a couple of times, sometimes it goes back to 100%. Yeah. And what is the time complexity for this? Well, the time complexity is going to be because we go through all characters. And in the strings, and the space complexity is going to be O1 for the regular case, because the size of the map or vector used is going to be fixed in terms of the letters of the alphabet. That's it. I hope you enjoyed the solution. If you did, like and subscribe, and stay tuned for more C++ problems. Thank you.